In the quiet dark beyond our atmosphere, every world around us carries some kind of danger. We call this place home, a small blue point drifting through a system built on collision, radiation, and slow decay. The calm we feel every morning rests on forces that could shift without asking permission. Tonight, we travel past a moon, quietly leaving us, through a belt built from a planet that never finished forming, across a world choking on its own poisoned air, and into storms larger than our entire planet. Stay through to the end, since the deepest danger waits for last. Take a slow breath. We are about to learn why the solar system is far more dangerous than anyone ever told you. Earth feels permanent. Solid ground beneath your feet. A sky that has looked the same for as long as anyone alive can remember. Astronomers confirm something different. Our planet occupies a narrow lane of safety inside a much larger and far more violent system, and that lane is narrower than most people assume. Picture our solar system as a quiet neighborhood. From the ground, everything looks calm. Step back far enough, and you see speeding traffic on every side, rocks the size of mountains crossing paths that come closer to us than comfort allows. Scientists have confirmed thousands of these objects pass near Earth's orbit every single year, most slipping by unnoticed. Most years, nothing happens. The trouble lies in what nearly did happen. In 1908, a chunk of space rock detonated above a remote forest in Russia, flattening trees across an area larger than a major city, releasing a force hundreds of times stronger than the first nuclear weapons. No crater formed. No warning arrived, just a flash, a shockwave, and silence afterward. That event sits in confirmed history, not theory. Researchers still debate what the object was made of, ice or stone, yet the destruction it caused remains beyond question. Had it arrived just hours later, given how fast our planet spins, an entirely different city could have vanished from the map that morning. Earth's atmosphere, the very thing keeping us alive, also works like a thin curtain stretched across the sky. It burns up small debris before impact, true, yet it cannot stop everything that comes our way. Larger objects punch straight through, and our tracking systems, even with modern technology, only catch a fraction of what crosses our path each year. Hold on to that thought, because the picture only grows stranger from here. Our planet is not simply floating in empty space, waiting patiently for whatever comes. It races around our star at roughly 18.5 miles every second, dragging us through a debris field littered with leftover material from the system's violent birth. Every collision avoided so far has carried an element of luck mixed into the physics. Some researchers now argue that civilization itself has been shaped by near misses we will never fully document, encounters too small to leave a crater, yet large enough to alter weather patterns or spark sudden panic among entire regions. This remains a working theory rather than settled fact, though the pattern within the data proves difficult to dismiss entirely. Here is the detail that should genuinely unsettle you tonight. The safety we feel each day relies on probability, not guaranteed protection. No global shield exists above our heads. No early warning system covers the entire sky at once. We are protected mostly by distance and chance, the same fragile combination that has worked for thousands of years and could fail without notice tomorrow morning. Listen closely, because something else deserves your attention. Beneath our feet, far older forces are stirring quietly, movements stranger and more ancient than any rock falling from above us. What lies beneath Earth's surface may prove just as unpredictable as anything falling from the sky above. Our closest companion in that sky carries its own quiet warning, and it has been slipping away from us for longer than anyone realized. Look up at the moon tonight, and it appears fixed in place, the same steady companion it has always seemed to be. That stillness hides an illusion. Confirmed measurements taken with laser reflectors placed on the lunar surface decades ago show our companion drifting outward away from Earth at roughly 1.5 inches every year. It sounds small. Stretched across millions of years, the consequences become enormous. The moon does far more than light up our night sky with quiet reflected glow. It stabilizes the tilt of our planet, the exact angle responsible for predictable seasons rather than chaotic, unpredictable climate swings. Remove that stabilizing influence slowly enough, and Earth's tilt could eventually begin to wobble in ways our ancestors never experienced or recorded. Scientists confirm this gravitational relationship sits at the center of our planet's stability. What remains less certain, still debated among researchers studying long-term orbital mechanics, is exactly how dramatic that wobble could eventually become once the moon drifts far enough away from us. Some models suggest mild shifts in climate patterns. Others point toward something closer to genuine chaos stretched across hundreds of thousands of years. As the moon continues moving away, its grip on our oceans weakens alongside it. Tides, the same rhythmic pull shaping coastlines and ocean life for countless generations, will grow gentler with each passing era. Entire ecosystems depending on strong tidal cycles for feeding and breeding could eventually struggle to maintain their current populations. This unfolds slowly, across a timescale longer than human history itself. Yet the direction stays locked in by physics, moving forward whether anyone notices the shift or not. Few documentaries mention the darker chapter behind this story. The moon never simply appeared beside Earth out of cosmic convenience. Leading scientific theory suggests it formed after a Mars-sized world slammed directly into early Earth, blasting debris into orbit that eventually clumped together into the moon visible tonight. That ancient impact carried enough violence to melt the surface of our entire planet completely. We are, in a very real sense, living beside the wreckage of a planetary collision that nearly erased everything before life had its chance to begin. Researchers studying lunar rock samples confirm chemical signatures matching this violent origin story, strengthening the case considerably with each new analysis. Mysteries still remain about the exact angle and speed of that ancient collision. Details scientists continue debating using increasingly detailed computer simulations. Picture the strange symmetry connecting past to future here. The same gravitational dance that once nearly destroyed a young planet now, ever so slowly, pulls our closest companion farther away from us with each passing year. Eventually, eclipses as we currently know them will stop happening entirely because the moon will appear too small in our sky to fully cover our star's blinding face. That future stretches far beyond any human lifetime to witness directly, yet it reveals something profound. Nothing within this system stays fixed forever, not even the object that has steadied our entire world since before life first stirred. Scientists confirm this slow drift will continue regardless of anything happening here on the surface below. If our nearest neighbor keeps drifting away year after year, the debris scattered farther out tells an even rougher story. Leftover rubble nobody ever bothered to clear from the neighborhood. Picture a vast ring of rock circling between Mars and Jupiter, and most people imagine a dense, crowded field, the kind shown in old science fiction films where ships dodge boulders every few seconds. Reality looks almost nothing like that crowded fantasy. The asteroid belt sits mostly empty across its enormous span. Scientists confirm the average distance between large objects out there stretches across millions of miles of open darkness. Spacecraft have flown through the entire region multiple times without registering a single near miss along the way. That detail should sound reassuring on its surface. It tells only part of a much stranger story. What makes the asteroid belt genuinely unsettling has nothing to do with crowding and everything to do with origin. This region likely represents a planet that never finished forming, material that should have come together into a fifth rocky world but never quite managed the task, broken apart instead by Jupiter's relentless gravitational pull reaching across the void. Trillions of fragments remain scattered there today, ranging from dust grains to objects hundreds of miles wide. The largest, a dwarf planet researchers have studied closely, using multiple spacecraft, holds enough mass to make up roughly a third of the belt's entire material by itself alone. These fragments never simply sit still, drifting harmlessly forever in quiet orbit. Gravitational interactions, mainly originating from Jupiter, occasionally fling pieces out of the belt entirely, sending them tumbling toward the inner solar system, toward our own front door, without much warning given. This sits as confirmed fact rather than speculation. Many of the asteroids that have struck Earth throughout its history originated from this very belt, nudged loose from their ancient orbits by forces that took millions of years to finally act. Researchers studying these gravitational disruptions describe certain regions within the belt as unstable zones, locations where an object's orbit can shift dramatically following the right alignment with Jupiter overhead. Step into one of these zones, even by pure accident, and an asteroid's future path becomes far less predictable than scientists would prefer. Few casual conversations ever touch on this particular detail. The belt holds more than simple rock scattered through space. Some asteroids out there contain massive amounts of metal, nickel, and iron in concentrations that would be considered priceless if anyone ever managed to mine them. Companies have seriously studied the economics of asteroid mining, theoretical for now, yet grounded firmly in real data about what these objects actually contain. That wealth arrives bundled with danger attached directly to it. The same metallic asteroids prized for their resources also rank among the densest and most destructive objects throughout the entire belt, should one ever find its way toward Earth's orbit unexpectedly. Scientists continue tracking the largest objects with reasonable confidence using ground and space-based telescopes. Smaller fragments, ones still large enough to cause regional devastation, remain far harder to monitor consistently across the belt's enormous volume. This gap in observation stays openly acknowledged within the broader scientific community. A planet that failed to form, broken into countless pieces, drifting in mostly empty space until gravity decides otherwise one day. Quiet for now, across this particular moment in time. Unpredictable across the longer stretches that truly matter. A failed planet can still reach across millions of miles to threaten us from a distance. An entire world that actually formed, then nearly died completely, has an even darker lesson waiting. Mars sits there in our night sky as a faint, reddish glow, calm and apparently lifeless from this enormous distance. That stillness marks the aftermath of catastrophe rather than the simple absence of one. Confirmed evidence gathered by multiple spacecraft shows Mars once held something Earth still enjoys today, a thick atmosphere paired with flowing liquid water across its surface. Ancient riverbeds carved into the rock remain visible from orbit even now, frozen in place like scars that never properly healed over time. Something stripped nearly all of that away from the planet permanently. Scientists confirm the leading explanation involves Mars losing its protective magnetic field billions of years ago, early in its history. Without that shield in place, the solar wind, a constant stream of charged particles racing outward from our star, slowly tore the Martian atmosphere apart, particle by particle, across countless centuries of exposure. Imagine standing in a room with no walls at all, every breath you take immediately swept away by relentless wind. That captures roughly what happened to an entire planet's air supply over an unimaginable stretch of time. This unfolded gradually, rather than overnight, which means Mars likely held on to livable conditions far longer than scientists once assumed possible, perhaps long enough for primitive life to gain a foothold before everything eventually collapsed around it. Researchers actively debate this exact possibility today. No confirmed evidence of past Martian life exists yet, though the conditions required were apparently present for a meaningful stretch of the planet's early history. Current missions continue searching for biological signatures buried within ancient rock layers, signatures that could reshape everything we understand about life across this solar system. Here lies the detail that should make you uneasy rather than simply curious about ancient history. Earth's own magnetic field, the very shield protecting us from this exact fate, carries no permanent guarantee either. Confirmed measurements show it has weakened gradually over recent centuries, and historical data reveals the field has flipped entirely multiple times across our planet's long and turbulent history. A full reversal would not strip our atmosphere away overnight. Scientists remain clear about that timeline. During the transition itself, our protective shield would weaken substantially, leaving us considerably more exposed to the very same solar particles that hollowed out Mars across geological timespans. Mars stands today as a preserved warning sign, a planet that essentially shows us a potential future should the protections we currently depend on ever fail completely across our own world someday. Mars still has weather worth mentioning, violent dust storms capable of swallowing the entire planet for weeks at a stretch, visible even from telescopes positioned here on Earth. These storms confirm that Mars remains geologically and atmospherically active in ways many people assume a dead world simply cannot achieve anymore. So Mars never quite settled into a pure graveyard, frozen and finished. It resembles something closer to a slow-motion crime scene, one where fresh evidence keeps accumulating the longer researchers study it carefully using ever more sensitive instruments sent from Earth across multiple missions. A world this similar to our own lost everything that once made it livable for any form of life. One neighboring planet keeps every drop of atmosphere Mars lost, and turns that abundance into something considerably worse to survive. If Mars represents a planet that lost its atmosphere entirely, Venus represents the opposite extreme, a world that kept everything and twisted it into a genuine nightmare. Confirmed surface temperatures on Venus reach roughly 870 degrees Fahrenheit, hot enough to melt lead completely on contact. Venus does not even hold the closest position to our star. Since Mercury claims that distinction instead, Venus simply runs hotter regardless, purely because of what surrounds its surface. A crushing blanket of carbon dioxide traps heat with brutal efficiency, ensuring Venus never properly cools down, neither during the night nor at any other point. Scientists confirm the surface pressure alone would crush an unprotected human body almost instantly, equivalent to standing nearly a mile beneath the ocean's surface back home. Venus produces rainfall too, though nothing resembling rain on Earth in any meaningful way. Confirmed atmospheric data reveals clouds made partly of sulfuric acid, drifting high above a surface so hostile that several early spacecraft sent to study it directly survived only minutes before failing completely under the strain. One particular mission still holds researchers' fascinated attention decades later. A Soviet lander touched down and managed to transmit images for less than 2 hours before the heat and crushing pressure destroyed it entirely from every direction. Those grainy photographs remain some of the only surface images of Venus ever captured by human technology. Here, the story turns genuinely unsettling for anyone watching from Earth tonight. Many scientists believe Venus may have once looked remarkably similar to our own planet, complete with oceans of liquid water billions of years in the past. Something triggered a runaway greenhouse effect, a chain reaction where rising heat caused more water to evaporate, trapping additional heat in turn, spiraling completely out of control until the oceans boiled away into nothing. This remains an active area of ongoing research rather than fully settled fact, though the underlying mechanism stays well understood and confirmed through detailed climate modeling. The same basic physics applies to any rocky world carrying an atmosphere, our own planet included in that equation. Researchers studying Earth's climate system openly acknowledge that runaway greenhouse conditions remain theoretically possible here as well, though current scientific consensus places Earth nowhere near that particular tipping point today. Venus stands as confirmed proof that this process moves well beyond mere theory. It happened to a planet sitting practically next door to us. Venus rotates so slowly that a single day there lasts longer than its entire year combined. Stranger still, it rotates backward compared to most planets within our system, and scientists continue debating exactly what ancient collision or gravitational event might explain such bizarre behavior. Some researchers suspect a massive impact billions of years ago flipped the planet's rotation entirely on its own. Others point toward gradual tidal effects accumulating across enormous spans of time instead. No confirmed answer exists yet within the scientific literature. What we know for certain runs deeper than speculation. Venus and Earth started out as close planetary cousins, similar in size, similar in composition, formed under remarkably similar conditions billions of years ago. One became a paradise capable of supporting life as we understand it. The other became one of the most hostile environments found anywhere across the entire solar system. The line separating those two wildly different outcomes turned out thinner than most people ever realize when they look up at our evening sky. Mercury sits closest to our star, a position that makes its behavior genuinely confusing once you examine the details closely. Most people assume the nearest planet must simply rank as the hottest, end of discussion. Confirmed data tells a far stranger tale entirely. Daytime temperatures on Mercury soar past 800 degrees Fahrenheit, hot enough to melt several metals outright within minutes. Nighttime across that same surface plunges to nearly 300 degrees below zero without warning. No other planet within our system swings between such violent extremes during a single rotation. The reason traces back to something Mercury almost completely lacks: a meaningful atmosphere. Earth's air acts like a blanket, holding heat and distributing it evenly across the entire globe day and night. Mercury carries essentially no such blanket, so heat escapes into space the instant our star's light disappears from view overhead. Despite roasting under direct exposure during the day, confirmed evidence shows actual ice exists on Mercury, hidden inside deep craters near its poles that never receive direct sunlight at any point. These permanently shadowed pockets stay cold enough, even this close to our star, to preserve frozen water across billions of years without melting. Scientists confirmed this discovery using radar imaging from Earth, later verified directly through spacecraft measurements taken up close. A planet capable of melting lead on one side can quietly hide ice on the other. A genuine contradiction that continues to surprise researchers studying it closely today. Worth understanding clearly. Mercury actually shrinks over time. Confirmed satellite imaging reveals massive cliffs stretching across the planet's surface, formed as its iron core gradually cooled and contracted across billions of years, wrinkling the outer crust much like fruit drying out slowly under sustained heat. Mercury has lost several miles in diameter throughout its long history, and that process may still be continuing quietly today. Researchers debate exactly how active this shrinking remains in the present moment. Some models suggest Mercury could still be slowly contracting even now, while others argue the process mostly finished long ago in the distant past. No fully confirmed answer exists within current research conducted by planetary scientists today. One more detail rarely surfaces in casual conversation about this small world. Mercury's massive iron core takes up roughly 85% of the entire planet's volume, an enormous proportion compared against Earth's own structure. Scientists still debate exactly why Mercury ended up so metal-rich, with leading theories suggesting an ancient violent collision may have blasted away much of its outer rocky layers, leaving mostly dense core material behind. If accurate, Mercury represents the wounded survivor of a planetary collision nearly as violent as the one believed to have created our own moon many years ago. Researchers studying this scarred world continue searching for additional clues buried within its dense, metal-heavy interior. This small, scorched world refuses to settle as simply a dead rock baking silently near our star. It carries hidden ice, a slowly shrinking surface, and quite possibly the scars of ancient planetary violence written directly into its structure. A planet sitting this close to our star can still hide ice within permanent darkness. The empty space stretching between every planet, the region most people assume holds absolutely nothing at all, hides far more danger than that quiet assumption suggests. Most people picture the space between planets as a vast, peaceful nothing, a calm void separating one world from the next without incident. Confirmed measurements paint a considerably more dangerous picture of what actually fills that gap. This region, called interplanetary space, stays filled with high-speed particles streaming constantly from our star, alongside cosmic rays arriving from far beyond our entire solar system's boundary. Scientists confirm these particles travel at incredible speeds, capable of damaging unprotected spacecraft electronics and posing serious risks toward any human traveling directly through that exposed space. Earth's magnetic field and thick atmosphere shield us from nearly all of this danger without most people ever noticing the protection at work. Step outside that shelter, and the threat becomes immediate and severe within a remarkably short window of time. Confirmed radiation data gathered during missions beyond Earth's protective shield shows astronauts traveling toward Mars would absorb dangerous radiation doses throughout the entire journey, levels significant enough to meaningfully raise long-term cancer risk, according to current ongoing research. This sits as measured fact rather than speculation dressed up as concern. It comes gathered directly by radiation detectors carried aboard real spacecraft during actual missions. Engineers actively research better shielding methods, though no perfect solution exists yet, and researchers openly acknowledge this remains one of the largest unsolved challenges standing between us and meaningful deep space travel. Rarely discussed openly, this same hostile space also stays full of dust, countless microscopic particles left over from the system's violent formation billions of years ago. Most particles measure smaller than a grain of sand, yet at the incredible speeds objects travel through space, even tiny dust particles carry enough force to damage spacecraft hulls and solar panels gradually over time. Spacecraft engineers confirm this danger directly through documented evidence. Multiple missions have recorded small impact craters appearing on solar panels and protective windows after extended time spent in space, evidence of countless tiny collisions accumulating silently throughout each individual mission across many years of travel. Most documentaries skip past another layer of danger entirely. Far beyond the particles and dust, this seemingly empty space also carries extreme temperature swings from one moment to the next. Without an atmosphere to regulate heat properly, anything exposed directly to sunlight can become scorching hot, while anything sitting in shadow plunges to extreme cold almost instantly afterward. Spacecraft must be engineered to survive both extremes simultaneously, sometimes within the very same orbit. Researchers studying long-term spaceflight increasingly describe interplanetary space using a striking comparison worth remembering. It behaves less like calm nothingness and more like an invisible storm, one that never fully stops, surrounding every planet within our system at all times without pause. Engineers designing future spacecraft must account for this constant exposure across every stage of a mission. What feels like emptiness when we glance upward at night actually qualifies, in confirmed reality, as an active and dangerous environment filled with radiation, debris, and extreme conditions that genuinely never pause for anyone passing through. Astronauts training for long missions spend considerable time preparing specifically for these hidden hazards. The space between worlds carries this much hidden danger on a quiet, ordinary day. Our own star occasionally decides to make that danger far worse, all at once, and with almost no warning given beforehand. Our star looks calm most days, a steady source of light and warmth that humanity has relied upon throughout its entire recorded history. Confirmed scientific data reveals something considerably more volatile happening beneath that calm appearance overhead. Our star regularly releases massive bursts of energy and charged particles, events known as solar flares and coronal mass ejections. These eruptions can release more energy within mere minutes than humanity has produced throughout its entire recorded history combined together. Most of these eruptions miss Earth entirely, simply because space stretches so vast and our planet occupies a tiny target within that emptiness. When one does point directly at us, the consequences can grow significant rather quickly. Confirmed historical record shows one of the most powerful events ever documented struck Earth in 1859. Telegraph systems across multiple continents failed completely within hours. Some operators reported sparks flying directly from their equipment, and brilliant auroras appeared in locations far closer to the equator than anyone had ever witnessed before that night. That event occurred during a period when humanity barely relied on electricity at all for daily life. Modern civilization now runs almost entirely on electrical and satellite infrastructure stretched across every continent. Picture that historical storm striking again, only this time against our current dependence on power grids. Scientists confirm a solar storm of similar strength hitting Earth today could cause widespread power grid failures, satellite damage, and communication blackouts lasting anywhere from days to potentially months across severely affected regions. Researchers studying this risk have estimated potential economic damage reaching into the trillions of dollars worldwide. This sits far from distant science fiction territory. In 2012, an eruption of comparable strength narrowly missed Earth entirely, passing through the exact orbital position our planet had occupied just 1 week earlier that summer. Scientists studying that near miss remain clear about how serious the outcome could have been had timing differed only slightly that week. What makes this threat especially unsettling involves the warning window itself. Time before a major solar storm strikes runs incredibly short, often amounting to less than a full day between detection and impact. Compare that against an asteroid, which scientists can sometimes track years or even decades ahead of arrival. A solar storm offers nowhere near that kind of luxury or lead time. Researchers continue developing better space weather monitoring systems, watching our star constantly for early signs of dangerous activity building. Current technology has improved detection significantly over recent decades, yet scientists openly acknowledge that predicting exact timing and strength remains genuinely difficult, even using today's most advanced tools available. Worth understanding clearly, our star follows an activity cycle lasting roughly 11 years, swinging between calmer phases and periods of intense magnetic disturbance. We are not always at equal risk throughout that cycle. During peak activity periods, the chances of a major eruption pointed toward Earth increase measurably, according to confirmed solar observation data stretching back many decades now. The warmth lighting our sky each morning carries a hidden volatility most people never pause to consider. Our own star carries this much hidden danger on an otherwise ordinary day. The largest planet within our system carries its own complicated relationship with the danger surrounding us, far from the simple protector most people assume it to be. Jupiter often earns description as our solar system's bodyguard, a massive planet whose powerful gravity supposedly shields Earth from incoming comets and asteroids alike. Confirmed science shows this popular story holds only partial truth, with the rest proving far more complicated than expected. Jupiter's mass dwarfs every other planet combined within our entire system. That enormous gravitational pull genuinely deflects many objects away from the inner solar system, sometimes flinging them out entirely into deep space beyond our reach. Researchers have documented this protective effect through detailed orbital simulations, stretching back across the system's long history. The same gravity capable of deflecting danger away from us proves equally capable of redirecting danger straight toward us instead. Confirmed studies show Jupiter has, on occasion, nudged distant objects loose from stable orbits and sent them tumbling into completely new paths, some crossing uncomfortably close to Earth's own orbital lane. Scientists describe this dual role using a fitting comparison worth remembering, less like a simple shield and more like an unpredictable gatekeeper, one that sometimes blocks danger and sometimes redirects it without warning given beforehand. Here stands confirmed proof of just how violent Jupiter's gravitational influence can become under the right conditions. In 1994, a comet torn apart by Jupiter's gravity years earlier finally collided with the planet directly. The impact created fireballs larger than Earth itself and left dark scars visible within Jupiter's atmosphere for months afterward, observed clearly by telescopes positioned worldwide. That comet never started out broken apart from the beginning. Jupiter's gravity ripped it into more than 20 separate fragments before the final collision occurred, demonstrating just how violently this planet can reshape objects wandering too close to its enormous pull. Researchers studying that event have used it directly to estimate how frequently Jupiter experiences major impacts of this kind, concluding collisions of meaningful size likely occur there far more often than scientists previously assumed possible. Jupiter radiates more heat outward into space than it actually receives from our star, confirmed through infrared measurements taken by multiple spacecraft over the years. Scientists still debate the exact internal process generating this extra heat, with leading theories pointing towards slow gravitational compression continuing deep within the planet's core, even after billions of years since formation. Jupiter also generates the most powerful magnetic field belonging to any planet across our entire system, confirmed many times stronger than Earth's own protective shield. This massive magnetic field traps intense radiation belts surrounding the planet, regions so dangerous that spacecraft must be carefully engineered just to survive brief passes through that exposure without suffering permanent damage. So Jupiter stands as neither purely protector nor purely threat to our small planet. It functions as both simultaneously, a planet whose enormous gravity reshapes the entire system around it, sometimes saving us from disaster, sometimes complicating our safety in ways scientists are still working to fully understand. Future missions plan to study this dual influence in far greater detail than ever before. The planet meant to protect us carries this much hidden danger woven into its enormous gravity. Researchers continue mapping exactly how often this redirection toward Earth's orbit actually happens across long stretches of time. Moons quietly orbiting nearby, worlds many people assume are simply frozen and lifeless, hide something scientists have only recently begun to understand themselves. Jupiter's moons often earn treatment as an afterthought, small frozen worlds circling a much larger neighbor nearby. Confirmed evidence reveals something far stranger hiding directly beneath their icy surfaces. One moon in particular has captured serious scientific attention over recent decades. Confirmed measurements from multiple spacecraft show a massive liquid ocean exists beneath its frozen outer shell, containing potentially more liquid water than every ocean on Earth combined together. That detail alone should reshape how anyone thinks about this small, distant world circling so far from our star. This hidden ocean stays liquid despite the extreme cold of deep space surrounding it, kept warm through a process scientists call tidal heating. As this moon orbits Jupiter, the planet's immense gravity constantly stretches and squeezes its interior, generating internal friction and heat similar to repeatedly bending a piece of metal until it warms inside your hands. This ocean offers nothing gentle or welcoming to any visitor arriving from Earth. Confirmed evidence suggests it may run chemically harsh, potentially rich in salts and minerals entirely different from Earth's own oceans, sitting beneath miles of solid ice under crushing pressure that would instantly destroy unprotected equipment sent to explore it. Scientists studying potential future missions toward this moon describe the engineering challenge as immense in scope. Any spacecraft hoping to drill through that ice and study the ocean directly would need to survive pressures and conditions far more extreme than anything encountered across Earth's deepest ocean floors. What makes this moon especially compelling to researchers, despite the obvious danger involved, comes down to chemistry. Confirmed chemical analysis of material ejected from cracks within the icy surface reveals organic compounds, the basic chemical building blocks associated with life as scientists currently understand it. This does not confirm life exists there directly. It confirms the right ingredients may already be present and waiting. Researchers remain genuinely divided over how likely life actually proves within that hidden ocean below the ice. Some point toward the chemical evidence as genuinely encouraging news. Others note the extreme conditions could make survival there nearly impossible for anything resembling life as we know it on Earth. This question remains entirely unresolved, an active area of ongoing scientific investigation across multiple research teams. Another moon orbiting Jupiter deserves serious attention here as well. Confirmed observations reveal it as the most volcanically active world found anywhere across the entire solar system, covered in active volcanoes constantly reshaping its surface in real time. The same tidal forces warming the hidden ocean elsewhere prove, on this neighboring moon, violent enough to melt solid rock entirely. Eruptions there have been confirmed reaching heights far taller than anything ever recorded across Earth's own volcanic history. Launching material hundreds of miles above the surface directly into the surrounding darkness of space, Jupiter's moons prove far from the lifeless, frozen afterthoughts most casual observers tend to imagine. They hide oceans, volcanic violence, and chemical mysteries that scientists are only beginning to fully investigate with modern instruments. Several future missions are already planned specifically to study these worlds up close. Hidden danger exists this far from our star, wrapped tightly in ice and permanent darkness. The planet known for its beautiful rings, considered by many the gentlest giant across our entire system, hides instability of its own behind that peaceful appearance. Saturn's rings often earn treatment as the calm, beautiful centerpiece of our solar system, a peaceful structure, presumably looking the same forever across countless generations. Confirmed scientific data reveals something far more urgent unfolding above that planet right now, in this present moment. These rings consist almost entirely of ice, mixed with smaller amounts of rock and dust scattered throughout, ranging in size from tiny grains to chunks larger than an average house. For a long stretch of time, scientists generally assumed the rings stood ancient, nearly as old as the solar system itself. Confirmed data gathered during a major spacecraft mission has overturned that long-held assumption considerably in recent years. Saturn's gravity constantly pulls ring material down into the planet's upper atmosphere, where it simply vanishes from view, raining down as a kind of icy precipitation, unlike anything Earth ever experiences directly. Scientists confirm this process, sometimes called ring rain, happens continuously and at a genuinely significant rate. Based on the confirmed rate of this material loss, researchers now estimate Saturn's magnificent rings may completely disappear within the next several 100 million years, with some models suggesting the actual timeline could run considerably shorter than that estimate. Within the vast timescale of our solar system's full history, several 100 million years sounds genuinely enormous on its face. Compared against the system's total age, it represents only a small fraction of that span, suggesting the rings we admire tonight may actually be a relatively temporary, recent feature rather than an ancient, permanent fixture overhead. This deepens the surrounding mystery considerably once you sit with it. If the rings prove relatively young, scientists must explain exactly where all that ice and rock originated from in the first place. Leading theories suggest the rings may have formed from a shattered moon or a captured icy object torn apart by Saturn's powerful gravity, though researchers continue actively debating the precise details involved. This stays genuinely unresolved within the broader scientific community, with multiple competing theories still under serious investigation using updated spacecraft data collected in recent years. Another layer of danger surrounds this beautiful structure that most casual observers never consider. The rings hold nothing resembling a smooth, solid disk, despite their appearance from a distance away. Confirmed close-up imaging reveals countless individual particles constantly colliding against each other, creating ripples, clumps, and even temporary moonlets that form and break apart repeatedly within the ring system itself. Some of these temporary formations have been confirmed, creating small gravitational disturbances strong enough to carve visible gaps directly within the rings, evidence of ongoing chaotic activity hidden within what looks, from Earth, like a perfectly still and peaceful structure overhead. Scientists studying Saturn's rings increasingly describe them using a striking comparison worth remembering, less like a fixed crown and more like a slow-motion demolition, beautiful from a distance, yet constantly being consumed by the very planet it surrounds tonight. Engineers studying this process continue refining their estimates using the latest spacecraft observations available from recent missions sent to study the planet up close. Something this beautiful is secretly falling apart at a measurable, accelerating pace. A moon orbiting nearby looks almost exactly like Earth from a distance until you understand precisely what its rain is actually made of underneath that familiar surface. Among every moon scattered across our solar system, one stands apart for a deeply unsettling reason. From orbit, this moon circling Saturn looks eerily familiar, complete with rivers, lakes, clouds, and steady rainfall. Confirmed spacecraft imaging reveals a world resembling Earth more closely than almost anywhere else humanity has ever studied directly. That familiarity ends the moment you understand what these features are actually made from underneath. This moon, called Titan, runs far too cold for liquid water to exist anywhere across its surface, with confirmed temperatures hovering around nearly 300 degrees below zero. Instead, its rivers and lakes stay filled with liquid methane and ethane, chemicals existing as gas here on Earth, but turning liquid within Titan's extreme cold environment. Scientists confirm this directly through detailed radar mapping conducted by spacecraft that studied Titan's surface extensively over multiple flybys. Entire lakes, larger than some found on Earth itself, confirmed and mapped in careful detail, sit filled with liquid natural gas beneath a thick, hazy orange atmosphere overhead. Titan experiences actual weather worth describing. Confirmed clouds that form, drift, and eventually release rainfall, much like Earth does. That rain consists of liquid methane falling from the sky, soaking into the ground and feeding the rivers and lakes below in a complete working cycle remarkably similar to Earth's water cycle, just built from entirely different raw ingredients. Researchers studying Titan describe this as one of the most extraordinary discoveries found anywhere across the solar system, the only other confirmed location besides Earth where stable liquid currently flows openly across a planetary surface. What makes this moon especially compelling to scientists involves its atmospheric chemistry directly. Titan's thick atmosphere runs rich in complex organic chemistry, the same basic category of carbon-based molecules considered essential building blocks for life as researchers currently understand it. This does not confirm life exists there, particularly given the extreme cold, though it does confirm the underlying chemistry stays remarkably active and complex. Some researchers have proposed that exotic forms of life, entirely different from anything found on Earth, could theoretically survive within Titan's liquid methane lakes, adapted to conditions Earth life could never tolerate for long. This stays highly speculative, openly acknowledged as such throughout the scientific community, with no confirmed evidence supporting it just yet. Another detail about Titan deserves serious attention here as well. Confirmed evidence suggests a liquid water ocean may exist deep beneath Titan's icy outer crust, similar in concept to the hidden ocean found on Jupiter's intriguing moon. If accurate, this would mean Titan secretly holds two completely different liquid environments stacked directly on top of each other, methane lakes above, salt water hidden far below the surface. Scientists studying Titan increasingly view it as one of the most promising locations across our entire solar system for understanding how chemistry might eventually organize into something resembling life, even under conditions completely foreign to anything found on Earth's own surface. This moon, looking so familiar from a distance, qualifies, in reality, as one of the strangest and most chemically alien worlds we have ever studied up close. A moon this far from our star can hide working weather and possible buried oceans beneath its surface. A planet spinning entirely on its side, tilted in a way nothing else across our system fully explains, waits next with a mystery scientists still cannot fully solve. Every planet within our solar system spins more or less upright, gently tilted like a slightly leaning top spinning across a table. Confirmed observations show one planet breaks that pattern entirely, tipped over so dramatically that it essentially rolls along its orbit rather than spinning in the normal manner. This planet, Uranus, carries an axial tilt of roughly 98 degrees, meaning its poles point almost directly toward and away from our star rather than up and down like every other major planet within the system. Scientists confirm this extreme tilt through decades of precise telescope measurement taken from Earth and from passing spacecraft. The result produces bizarre seasons, unlike anywhere else found across our system. Confirmed data shows each pole experiences roughly 42 years of continuous sunlight, followed by 42 years of complete darkness, an extreme version of seasons that would feel unimaginable to experience firsthand as a resident. Scientists have not confirmed exactly why Uranus ended up tilted this dramatically in the first place. Leading theory suggests a massive collision, likely involving an object roughly the size of Earth, struck the young planet early in its history and knocked it onto its side permanently going forward. Researchers studying this theory through computer simulations confirm the physics works convincingly enough, since a single violent impact could absolutely explain the extreme tilt observed today across the planet. What remains genuinely unresolved involves finding direct physical evidence of that ancient collision, something difficult to locate billions of years after the fact occurred. Something complicates the simple collision story even further upon closer inspection. Confirmed observations show several of Uranus's moons orbit neatly aligned with the planet's sideways tilt rather than following the more typical orbital pattern seen elsewhere across our system. This alignment suggests these moons may have formed after the tilting collision occurred, built from debris kicked loose during that same violent event long ago. Scientists continue actively debating the precise sequence of events that led here. Some researchers propose multiple smaller impacts rather than one single massive collision, while others maintain the simpler single impact theory remains the strongest explanation currently available given the evidence. Another genuinely strange detail about this planet rarely reaches casual conversation. Confirmed measurements reveal Uranus radiates very little excess internal heat compared against other giant planets within our system, a notable contrast against Jupiter and Saturn, both confirmed to radiate considerably more heat than they receive directly from our star. Scientists still debate why Uranus behaves so differently in this particular regard. Some propose the same ancient collision that tilted the planet may have also disrupted its internal heat-generating processes somehow. This remains an open question within ongoing planetary research conducted today. Uranus also holds the distinction of carrying the coldest planetary atmosphere ever directly measured anywhere across our entire solar system, confirmed colder than even more distant Neptune despite sitting closer to our star overall. Researchers find this temperature anomaly genuinely puzzling and continue studying potential explanations for the strange reading. This sideways planet, often dismissed as simply odd or unremarkable, actually represents one of the most violent and unresolved mysteries found within our solar system's early history. A single ancient collision could permanently tip an entire planet onto its side without warning. Forces required to generate winds faster than anything Earth has ever recorded wait just beyond Uranus, within reach of our next stop. Neptune sits at the far edge of our planetary system, a distant blue world so far from our star that sunlight takes hours just to reach it. Confirmed measurements reveal something deeply unsettling, hiding within that calm, distant blue color visible from telescopes. This planet hosts the fastest winds ever directly measured anywhere across our entire solar system, confirmed repeatedly by every instrument sent to study it. Confirmed data gathered by spacecraft instruments shows wind speeds reaching over 1,000 miles per hour, several times faster than the strongest hurricane ever recorded across Earth's own history. Picture the most destructive storm imaginable here at home, then multiply that violence several times over, and you begin approaching the conditions confirmed swirling constantly within Neptune's atmosphere right now, far from any human eyes watching closely. What makes this especially strange involves the underlying math itself. Neptune receives barely any heat from our star, sitting so distant that direct sunlight there registers incredibly faint. Scientists would generally expect a planet receiving so little outside energy to host calmer, quieter weather patterns, not the most violent storms found anywhere across the entire system. Confirmed measurements show Neptune radiates significantly more heat outward than it actually receives from our star, similar to the unexplained behavior observed on Jupiter as well across that gas giant's own surface. Researchers believe this internal heat, rising up from somewhere deep within the planet, drives these extraordinarily powerful winds across its surface. The exact source of that internal heat remains genuinely unresolved within current research. Leading theories suggest ongoing gravitational compression deep within Neptune's core, slowly releasing energy that has been building since the planet first formed billions of years ago. This stays an active area of scientific investigation rather than settled, confirmed fact. Something makes Neptune's atmosphere even more dramatic upon closer study. Confirmed observations from spacecraft revealed a massive dark storm system roughly the size of Earth itself, drifting through Neptune's atmosphere during one historic flyby decades ago. When telescopes later searched for that exact storm, it had completely vanished, eventually replaced by entirely new storm systems forming elsewhere across the planet. Scientists studying these shifting storms describe Neptune's atmosphere as remarkably dynamic and unpredictable, constantly forming and dissolving massive weather systems in ways that remain difficult to fully model using current available technology and instruments. Another striking detail about this distant world deserves mention here. Neptune's largest moon orbits backward, moving opposite the direction of the planet's own rotation, an unusual pattern, strongly suggesting this moon arrived captured later by the planet's powerful gravity rather than forming alongside Neptune originally. Researchers studying this captured moon have found confirmed evidence of active geysers erupting from its icy surface, blasting nitrogen gas and dark material high above the ground, despite the moon's extreme distance from any meaningful warmth. Scientists hope future missions will study these eruptions in far greater detail than current instruments allow today. This distant, seemingly calm blue planet qualifies, in confirmed reality, as one of the most violently active worlds found across our entire solar system, hiding ferocious winds and mysterious internal heat far from our star's gentle reach. Conditions grow this extreme even within our system's known boundaries, past every planet entirely. Within the frozen region, where icy worlds defy nearly every model scientists have built, something stranger waits to be explored. Beyond Neptune, far past the planets most people learn about in school, lies a vast frozen region scientists call the Kuiper Belt. Confirmed observations reveal far more than empty space out there. Instead, a sprawling field containing hundreds of thousands of icy objects, some large enough to be considered dwarf planets in their own right. For decades, scientists assumed this distant region would behave predictably, frozen leftover material from the solar system's early formation, quietly orbiting without much surprise expected by anyone watching closely from observatories on Earth. Confirmed discoveries over the past several decades have repeatedly overturned that simple assumption held by earlier researchers studying the data. This region holds far more diversity than anyone initially expected to find scattered throughout this distant frozen frontier of our solar system. Confirmed observations reveal objects ranging from small icy fragments to substantial worlds, some accompanied by their own moons, others showing surprising evidence of past geological activity despite the extreme cold and distance from any meaningful warmth. Several objects within the Kuiper belt follow orbital paths that confirmed calculations struggle to fully explain using current understanding of the solar system's gravity alone. Some objects cluster together in ways suggesting an unseen gravitational influence may be shaping their behavior from somewhere far beyond what telescopes can currently see. This observation has led some researchers to propose the existence of an additional, undiscovered planet hiding within or beyond this distant region, though this remains genuinely unconfirmed and actively debated throughout the scientific community today. Researchers have found something else considerably surprising during recent study. Confirmed spacecraft imaging of objects within this region has revealed evidence of past geological activity, including possible signs of ancient cryovolcanism, eruptions of icy material rather than molten rock, on worlds so cold and distant that scientists previously assumed all geological activity would have ceased entirely billions of years ago. This finding genuinely challenged existing models held by the research community. Researchers are still working to understand exactly how these distant, frozen worlds manage to generate enough internal heat to remain geologically active for so long, given how little warmth they receive from our distant star overhead each day. Another striking detail about this region deserves attention here too. Confirmed data shows some Kuiper belt objects appear to be binary systems, two icy worlds locked together, orbiting a shared center of gravity rather than one simply circling the other in typical fashion. Several of these binary pairs have been studied closely, revealing complex orbital relationships that continue surprising researchers studying their formation. Scientists studying the Kuiper belt increasingly describe it less as a quiet, predictable graveyard of leftover material, and more as an active, complex region still capable of producing genuine scientific surprises with each new observation collected. New telescopes coming online within the next decade should reveal considerably more about this hidden frontier than ever before possible. This distant frozen belt, often imagined as simple, dead, and unchanging, continues revealing complexity that challenges long-held assumptions about how our solar system actually formed and continues behaving even today. Researchers expect many more surprises as observation technology continues improving year after year. Among everything discovered within this mysterious region, one small world in particular forced scientists to completely rewrite what they thought they understood about distant, icy planets sitting at the edge of everything familiar. For decades, Pluto sat at the edge of public imagination as a small, frozen, lifeless world, distant enough that little detailed information existed about its actual surface. Confirmed spacecraft imaging finally changed that picture completely, revealing a world far stranger than anyone had predicted beforehand. When a spacecraft finally captured close-up images of Pluto, scientists were stunned by a massive, pale, heart-shaped region clearly visible across its surface. Confirmed analysis revealed this striking feature consists primarily of frozen nitrogen, methane, and carbon monoxide ices, distinct from the surrounding terrain stretching beyond it. That heart-shaped region alone would have qualified as a remarkable discovery on its own. What scientists found underneath it proved even more surprising to the entire research community. Confirmed gravitational and surface data strongly suggest a liquid ocean may exist beneath Pluto's icy heart-shaped region, hidden far below the frozen surface, kept from completely freezing through internal heat and the unique chemistry of compounds mixed within that hidden water below. This finding initially seemed nearly impossible to many researchers studying the data. Pluto sits so distant from our star and runs so small compared against larger planets that scientists assumed it should have frozen solid throughout long ago in its history. Confirmed evidence increasingly suggests otherwise, complicating the earlier assumption considerably. Researchers studying this discovery propose that ancient impacts, combined with specific antifreeze-like chemical compounds, may have helped keep this hidden ocean from solidifying completely, even across billions of years of extreme surrounding cold. This stays an active area of scientific investigation, with researchers continuing to refine their models using updated spacecraft data. Scientists found something else considerably surprising during this mission. Confirmed imaging revealed mountains on Pluto's surface, made of solid water ice, towering several miles high, essentially as hard as solid rock given the planet's extreme cold temperatures. Nearby, confirmed evidence shows smooth, young-looking plains completely free of impact craters, suggesting active geological processes have resurfaced this region relatively recently in cosmic terms. This combination genuinely puzzled researchers studying the images closely. A small, distant world should not show this much recent geological activity according to older planetary models built decades earlier. Scientists are still working to fully understand what internal processes could be powering this unexpected activity so far from any significant source of heat. Another detail about Pluto's surroundings deserves understanding here as well. Confirmed observations reveal Pluto has multiple moons, with its largest companion so massive relative to Pluto itself that the two technically orbit a shared point of gravity located between them, rather than one simply circling the other in the more typical arrangement. Scientists describe this as more closely resembling a double-world system than a standard planet and moon relationship, a genuinely unusual configuration rarely observed elsewhere across our solar system's many worlds. This small, distant world, once dismissed by many as simply an icy, unremarkable rock, turned out to be hiding a heart-shaped region, a possible buried ocean, towering ice mountains, and surprisingly recent geological activity beneath its surface. Researchers continue calling for follow-up missions to study these mysteries even more closely. A world this small and distant can hold this many secrets at once. Objects occasionally leaving this frozen region entirely, streaking toward the inner solar system, carry far more unpredictability than their beautiful glowing tails ever suggest. Comets have long earned description using a simple, almost comforting phrase: dirty snowballs drifting quietly through space. Confirmed modern research reveals that description barely scratches the surface of how complex and genuinely unpredictable these objects actually prove to be. A comet's core, called its nucleus, is indeed made largely of ice mixed with rock and dust, confirmed through direct spacecraft imaging and detailed sample analysis conducted by multiple research teams over the years. As a comet approaches our star, that ice begins vaporizing, releasing gas and dust that form the glowing tail so often associated with these visitors. That much matches the simple description fairly closely. What happens beneath the surface grows considerably more complicated upon closer study. Confirmed spacecraft missions studying comet nuclei up close reveal surfaces that are remarkably fragile, porous, and structurally weak, closer in some ways to a loosely packed snowbank than a solid, predictable rock. This fragility creates a genuine problem for scientists trying to predict exactly how comets will behave under stress. Confirmed observations have repeatedly shown comets breaking apart unexpectedly as they approach our star, sometimes splitting into multiple pieces with little advance warning given. Scientists studying these breakup events admit predicting exactly when and why a specific comet will fragment remains genuinely difficult, even with modern observation technology available today. This unpredictability matters considerably, given comets' long history with Earth itself across countless centuries of recorded observation. Confirmed scientific evidence suggests comet impacts may have delivered significant amounts of water to early Earth, potentially contributing to the oceans that eventually made life here possible at all. Researchers continue actively studying exactly how much of Earth's water arrived this way, with estimates varying across different studies and models. Unlike many asteroids, which scientists can often track for years or decades using established, predictable orbits, certain comets arrive from far beyond our solar system's outer boundary, appearing with relatively little advance warning before becoming visible to telescopes here on Earth. Scientists refer to these as long-period comets, confirmed to follow orbits that can take thousands or even millions of years to complete a single loop around our star. Because their approach often happens quickly once they finally become visible, the warning time before any potential close encounter with Earth can run considerably shorter than astronomers would prefer for comfort. Confirmed, historical evidence suggests comet fragments may have caused significant impact events throughout Earth's deep history, distinct from typical asteroid impacts studied elsewhere. Researchers continue investigating several ancient impact sites to determine whether comet material, rather than asteroid material, carried responsibility for the damage found there. New dating techniques continue refining these investigations year by year, slowly narrowing down the possibilities. Comets prove far from simple, predictable snowballs lazily drifting through open space. They run fragile, prone to breaking apart suddenly, and capable of arriving from the depths of space with relatively little warning compared against other threats scientists track more easily. Astronomers continue searching the sky nightly for new arrivals that might catch everyone off guard. Objects from the frozen outer edges of our solar system can arrive this unpredictably without much notice. The very star sitting at the center of everything, the one we have trusted as stable since the beginning of recorded history, carries instability of its own worth examining closely. Throughout human history, the star at the center of our solar system has represented permanence, the one constant rising and setting every single day without fail across generations. Confirmed, scientific research reveals this sense of permanence is, in important ways, an illusion built on the relatively short span of recorded human history available to study. Confirmed data shows our star follows a roughly 11-year activity cycle, swinging between periods of relative calm and periods of intense magnetic activity overhead, visible to instruments tracking the surface closely. During active phases, sunspots, flares, and eruptions increase considerably, confirmed and tracked closely by solar observatories positioned around the world. This cycle itself stays well understood and not particularly alarming taken on its own. What concerns researchers more involves evidence suggesting our star's behavior has not always followed such a neat, predictable pattern throughout its longer history. Confirmed historical and scientific evidence points toward an extended period, several centuries ago, when solar activity dropped dramatically, sunspots nearly vanishing entirely for decades at a stretch during that span of time. This quiet period coincided with notably colder temperatures across parts of the world, leading many researchers to suspect a meaningful connection, though the exact relationship remains actively studied and debated today. Scientists studying ice core samples and ancient tree rings have found confirmed evidence of extreme solar particle events buried in the deep past, events significantly more powerful than anything humanity has directly witnessed and recorded using modern instruments available now. One such event, confirmed through radioactive isotope evidence preserved within ancient trees, struck Earth roughly 1,200 years ago, releasing a burst of radiation far more intense than the largest storms recorded throughout modern history. Had an event of that magnitude struck during today's technology-dependent civilization, the consequences could have proven severe across multiple systems. Researchers studying these ancient extreme events, sometimes called superflares, continue investigating exactly how frequently our star produces eruptions of this magnitude across its lifespan. Confirmed evidence suggests these events happen rarely, yet considerably more often than scientists originally assumed before this evidence surfaced. Astronomers studying other stars similar in age and composition to our own have confirmed observing far more violent superflare events occurring on some of those distant stars, events dramatically more powerful than anything ever recorded from our own star directly. This raises a genuinely open question throughout the scientific community about whether our star remains fully capable of producing similarly extreme events someday. This stays an active, unresolved area of research among specialists. Some scientists argue our star's specific characteristics make events of that extreme magnitude considerably less likely going forward. Others caution that the relatively short span of detailed human observation may simply prove too brief to rule out rare, extreme events occurring naturally within longer cycles we have not yet fully witnessed firsthand. Researchers continue gathering data from telescopes worldwide to narrow down which view ultimately holds more weight in the end. The steady, reliable star anchoring human life and history may prove considerably more volatile across longer timescales than our brief recorded history has allowed us to fully appreciate. Our star carries this much uncertainty stretched across centuries of quiet observation. A single, sudden eruption striking directly, fast enough that modern civilization has almost no time to prepare, waits as a genuine possibility worth understanding fully. Modern civilization runs on an invisible foundation most people never think about directly, a vast interconnected web of electrical power grids, satellites, and communication systems spanning the entire planet. Confirmed scientific research reveals this foundation proves considerably more fragile than most people realize, vulnerable to a single event originating from our own star. A coronal mass ejection occurs when our star releases an enormous burst of charged particles and magnetic energy directly into open space. When one of these eruptions happens to point directly toward Earth, confirmed physics shows the resulting collision with our planet's magnetic field can trigger serious, widespread disruption across multiple systems. Scientists confirm the most severe documented example struck in 1859, an event so powerful that telegraph systems failed across multiple continents and brilliant auroras appeared in places that almost never witnessed them under normal conditions. At that point in history, humanity's electrical infrastructure remained minimal, limiting the overall damage considerably compared against today. Engineering studies confirm an event of similar strength striking today could induce dangerous electrical surges throughout power grids worldwide, potentially damaging or destroying massive transformers, forming the backbone of electrical distribution systems across entire continents. Here lies the detail that should concern anyone relying on modern infrastructure, which essentially describes everyone alive today. These massive transformers are not simple components sitting on store shelves ready for quick replacement. Confirmed industry reports show many take many months to manufacture, often built only after a specific order gets placed, with limited spare inventory existing anywhere across the world. Researchers studying this vulnerability have repeatedly warned that a severe enough solar event could potentially leave large regions without reliable electrical power for an extended stretch, possibly lasting months rather than days, depending on severity and how many transformers across various regions face damage simultaneously. This is grounded firmly in confirmed engineering assessments conducted by power grid operators and government agencies studying the genuine risk this scenario presents to daily life. Modern society depends heavily on satellite systems for navigation, communication, and weather forecasting across every region. Confirmed evidence shows severe solar storms can damage satellite electronics directly and interfere significantly with the very navigation signals millions of people rely upon every single day without ever thinking about the system. Underneath, scientists monitoring solar activity have specifically pointed back toward the near-miss event of 2012 as a sobering case study, an eruption of comparable strength that passed through Earth's exact orbital position just 1 week after our planet had occupied that same location in space. Researchers studying that confirmed near miss have stated clearly that modern society likely was not fully prepared for the disruption such an event would have caused, had timing differed by only a relatively small margin that week. Space weather forecasting has improved considerably in recent years, with scientists now able to provide at least some advance warning before the most dangerous particles actually arrive at Earth. Even with these improvements, researchers openly acknowledge meaningful warning time before a major event remains limited, often amounting to less than a full day in the most severe scenarios imaginable. The very star making life on Earth possible also carries the confirmed capability to disrupt modern civilization significantly within a remarkably short window of time. This vulnerability has not been fully solved by current technology. The failed worlds scattered throughout our solar system, planets that never survived long enough to matter, reveal just how violent our system's early history truly was. The solar system we observe today, 8 confirmed planets orbiting in relatively stable, predictable paths, represents only the survivors of a much longer story. Confirmed scientific research increasingly reveals a far more violent and chaotic early history, filled with planets that never made it to the present day at all. Early in our solar system's formation, scientists confirmed that significantly more planetary bodies existed than survive today across the system, scattered throughout the original disk of material orbiting our young star. Through repeated collisions, gravitational ejections, and violent mergers, this early chaotic population gradually narrowed into the more stable arrangement we now recognize overhead. This sits as confirmed evidence rather than speculation built on imagination alone. Support for this violent early history comes from multiple sources, including detailed computer simulations, the chemical composition of meteorites, and the scarred, cratered surfaces still visible on planets and moons throughout our system today, decades after the chaos first unfolded. Leading scientific theory suggests Earth's own moon formed when a Mars-sized planet, sometimes referred to by researchers using a working name, collided directly with early Earth in a collision violent enough to melt our planet's surface completely during that ancient impact. That colliding world no longer exists today as a separate planet of its own. Confirmed evidence suggests its material became thoroughly mixed into both Earth itself and the debris that eventually formed our moon, a planet essentially erased from existence, yet still present all around us in ways most people never consider while looking upward. Researchers studying gravitational dynamics propose that several other planetary bodies likely formed early in our solar system's history before being completely ejected entirely, flung out into deep interstellar space by gravitational interactions with the larger planets we recognize today. These ejected worlds, sometimes called rogue planets once cast loose from any star's gravitational influence, would now drift alone through the vast emptiness between stars, confirmed in concept through computer modeling, though scientists have not yet definitively identified specific examples originating from our own solar system directly. Confirmed studies of ancient meteorites reveal chemical signatures suggesting they originated from planetary bodies no longer existing today, worlds that formed early, then were destroyed entirely through violent collisions before the solar system fully settled into its current, more stable configuration overhead. Researchers analyzing these meteorite samples have identified distinct chemical fingerprints that do not match any surviving planet within our solar system, strong evidence supporting the existence of these long-lost worlds. Even without being able to directly observe them today, scientists studying this violent early period increasingly describe our current solar system less as a peaceful, orderly creation, and more as the surviving aftermath of an extended demolition process that eliminated far more worlds than it ultimately preserved going forward. New simulations continue refining exactly how many worlds may have been lost during that ancient chaos long before Earth ever settled into its current stable orbit. The calm, stable solar system we observe and rely upon today is, according to confirmed scientific evidence, built directly upon the wreckage of planets failing to survive their own violent formation. Entire worlds were erased during our solar system's early history without leaving obvious traces behind. One particular near miss reveals just how close our own system came to losing considerably more than it ultimately did during that turbulent period. Every planet currently orbiting our star survived an early period of intense chaos and violence stretching across billions of years. Confirmed scientific evidence reveals that survival was never guaranteed from the start, and at least one moment in our solar system's history came remarkably close to eliminating an entire world we still rely upon today. Scientists studying the detailed history of planetary formation have identified a period, sometimes called the Late Heavy Bombardment, a confirmed era when impact rates across the inner solar system spiked dramatically, far beyond the relatively calm conditions we experience now. Confirmed evidence supporting this violent period comes directly from lunar rock samples collected and brought back to Earth, showing a notable cluster of impact events all occurring within a relatively narrow window of time, rather than spreading evenly across the Moon's entire history of existence. Scientists continue actively debating exactly what triggered this surge in impacts across the inner system. Leading theory suggests a significant shift in the orbits of our outer giant planets, particularly Jupiter and Saturn, disrupted the orbits of countless smaller bodies throughout the solar system, sending many of them tumbling inward toward the rocky inner planets. This proposed planetary migration theory remains one of the most actively researched topics within modern planetary science. Supported by confirmed computer simulations that successfully recreate many observed features of our current solar system, yet still containing genuine uncertainty about the precise sequence and timing of events involved. Something here should genuinely unsettle anyone considering how fragile this period truly proved to be. If Jupiter and Saturn's orbital shift had unfolded somewhat differently, confirmed simulations suggest the resulting gravitational chaos could have grown considerably more severe, potentially destabilizing the orbits of inner planets, Earth included, far more dramatically than what actually occurred during that ancient period. Researchers running these simulations have found that relatively small differences in starting conditions can produce dramatically different outcomes across the model. Some preserve a stable inner solar system similar to what we observe today, while others produce scenarios where planets collide, merge, or get ejected entirely from the system. This sensitivity reveals something profound about our own existence here on Earth. The stable, predictable solar system we currently inhabit was not necessarily the only possible outcome of that ancient chaos, nor perhaps even the most likely one. According to the range of results these confirmed simulations consistently produce, confirmed evidence suggests Mars may have once been considerably larger and potentially more hospitable before this turbulent period struck, with some of this chaotic bombardment activity potentially contributing directly towards stripping away much of its original atmosphere and surface water. Researchers studying Mars's ancient history continue investigating exactly how much of its current hostile condition traces directly back to this violent chapter within our solar system's deep past, an active and ongoing area of dedicated scientific study today. The calm, orderly arrangement of planets we observe and depend upon today was never actually guaranteed by anything. Confirmed scientific evidence suggests our solar system narrowly avoided considerably more severe disruption during its formative years, shaped by forces that could easily have unfolded quite differently. Our solar system came this close to losing far more during its earliest formation. The vast cloud of icy material still surrounding us today, hidden so far away that most people forget it even exists, holds far more hidden material than anyone fully comprehends. Far beyond every planet, beyond even the frozen Kuiper belt, lies a region scientists believe completely surrounds our entire solar system in every direction at once. Confirmed theoretical models describe this distant shell, called the Oort cloud, as the true outer boundary of our star's gravitational influence reaching into deep space. This region has never been directly observed or photographed by any telescope. Confirmed evidence for its existence instead comes indirectly, primarily through detailed observation of long-period comets, whose extreme, looping orbits strongly suggest they originate from an enormous, distant reservoir of icy material surrounding our entire system. Scientists estimate this distant cloud could contain trillions of icy objects, vastly outnumbering every object found within the Kuiper belt or asteroid belt put together. This staggering number remains a theoretical estimate, confirmed through orbital mathematics rather than direct visual confirmation, since no telescope has ever directly imaged the Oort cloud itself across the void. Scientists continue actively debating exactly how this cloud originally formed billions of years ago. Leading theory suggests much of this icy material was gravitationally ejected outward from the inner solar system during its early, chaotic formation, eventually settling into this enormous, distant shell surrounding everything we recognize today. This theory stays supported by confirmed computer modeling, yet considerable uncertainty persists regarding the cloud's precise structure, total mass, and overall behavior, given how impossible direct observation remains using current available technology. Passing stars, even ones currently many light years away from us, can occasionally exert enough gravitational influence to nudge objects within the Oort cloud loose from their extremely distant, stable orbits, sending them tumbling inward toward the inner solar system across enormous spans of time. Researchers studying stellar movement through our galactic neighborhood have identified specific stars that, according to confirmed orbital calculations, will pass relatively close to our solar system at some point in the distant future, potentially close enough to meaningfully disturb this distant icy shell surrounding us. This does not mean a sudden impact sits imminent on any practical timeline. Scientists remain clear that any resulting increase in comet activity would unfold across an enormous timescale, likely spanning many thousands of years before any noticeable difference reaches the inner solar system where Earth resides quietly. Because the Oort cloud sits so unimaginably distant, any object dislodged from its outer edges would take an extraordinarily long time, potentially millions of years, to fall inward and finally become visible to telescopes here on Earth, only revealing itself once it finally approaches close enough to begin glowing in the dark. This means our solar system stays essentially surrounded, in every direction at once, by an enormous reservoir of material capable of sending unpredictable visitors toward us across timescales far longer than human civilization has ever existed. Scientists continue refining their models of this distant region using indirect evidence collected over decades. The seemingly empty darkness surrounding our entire solar system actually contains an enormous, confirmed reservoir of hidden material, invisible directly, yet capable of shaping events here on Earth across timescales almost impossible to fully comprehend. Our system stays surrounded this completely by hidden material on every side. Objects that do not originate from within our solar system at all, visitors arriving from entirely different star systems altogether, pass through more often than most people would ever guess. For most of recorded history, scientists generally assumed every comet and asteroid observed originated from within our own solar system, born from the same swirling cloud of material that formed our star and planets billions of years ago. Confirmed discoveries in recent years have completely overturned that long-held assumption among researchers. In 2017, astronomers confirmed detecting the first known object to enter our solar system from interstellar space, originating from somewhere entirely beyond our own star's gravitational influence. This object moved on a trajectory that confirmed calculations showed was not bound to our star at all, meaning it would pass through briefly and then leave permanently. never to return again. That discovery alone reshaped scientific understanding considerably across the field. Just 2 years later, astronomers confirmed detecting a second interstellar visitor, this time identified clearly as a comet, providing scientists with even more confirmed evidence that objects from other star systems regularly pass through our own neighborhood. Based on these confirmed detections, researchers now estimate interstellar objects pass through our solar system considerably more frequently than anyone previously assumed possible, simply going undetected in the past due to limited observation technology and how faint and fast-moving these objects typically appear from Earth. Scientists studying these confirmed visitors describe them as genuinely strange in important ways worth examining. The first detected object showed an unusual elongated shape, unlike most comets or asteroids studied within our own system, and confirmed observations revealed it accelerated slightly as it moved away from our star in a manner that puzzled researchers considerably at the time. Researchers continue actively debating the exact explanation behind that unusual acceleration. Leading theory suggests trace amounts of vaporizing material on the object's surface provided a subtle propulsive effect, similar to how comets behave, though confirmed visual evidence of this outgassing process was never directly observed, leaving the explanation somewhat unresolved among scientists today. These confirmed interstellar visitors prove our solar system is not a sealed, isolated environment cut off from everything else. Material constantly drifts in and out, crossing distances between entire star systems, carrying with it the possibility of material, and potentially even microscopic organisms, transferred between completely separate stellar neighborhoods across the galaxy. This concept, sometimes called panspermia, remains genuinely speculative and unconfirmed as an explanation for how life might spread between star systems. Scientists treat it as a serious theoretical possibility worth investigating further, not a settled or proven mechanism backed by direct evidence. Astronomers now actively search specifically for these interstellar visitors using dedicated survey telescopes built for that exact purpose, anticipating that improved technology coming online soon will detect significantly more of these objects than the rare few confirmed so far. Researchers expect this increased detection capability to reveal that interstellar visitors are a regular, ongoing occurrence throughout our solar system's history, rather than the rare anomaly they currently appear to represent based on limited historical observation. Our solar system stays far from the isolated, sealed-off neighborhood many people assume it to be. Confirmed evidence shows objects from entirely different star systems regularly pass through, carrying mysteries scientists are only just beginning to study directly. Visitors from other star systems reach us this easily on a regular basis. Earth's own safe zone, the narrow region scientists describe as suitable for life at all, sits far narrower than most people would ever guess. Earth occupies a special position within our solar system, a region scientists often refer to as the habitable zone, the narrow range of distance from our star where temperatures allow liquid water to exist stably across a planet's surface. Confirmed calculations show this zone runs considerably narrower than most people tend to assume. Move Earth even modestly closer toward our star, and confirmed climate modeling suggests a runaway greenhouse effect, similar to what likely occurred on Venus billions of years ago, could potentially take hold, boiling away our oceans entirely over an extended period of time. Move Earth modestly farther away instead, and confirmed modeling suggests our planet could plunge into a runaway freezing effect, locking oceans into thick ice and dramatically reducing the energy available to sustain the climate systems life depends upon for survival. The margin separating a stable, livable Earth from one of these two extreme outcomes runs, according to confirmed scientific calculation, considerably smaller than the comfortable, wide margin most people tend to imagine when picturing our position. Earth's habitability depends on more than just distance from our star alone. Factors including atmospheric composition, the presence of a strong magnetic field, plate tectonics regulating long-term carbon levels, and even our large stabilizing moon, all confirmed to play essential roles in maintaining the stable conditions life genuinely requires to persist. Remove or significantly weaken any one of these supporting factors, and scientists confirm Earth's habitability could become considerably less certain, even while remaining within the basic distance range theoretically suitable for liquid water to exist. Confirmed astrophysical research shows our star is gradually growing brighter over extremely long timescales, a natural part of stellar evolution confirmed through detailed study of similar stars across various stages of their own life cycles. Scientists calculate that within roughly 1 billion years, our star's gradually increasing brightness will likely push Earth outside the inner edge of the habitable zone entirely, triggering the kind of runaway heating that scientists believe doomed Venus billions of years earlier in its own history. This timeline extends far beyond any meaningful human concern today, yet it confirms something profound about our position. Earth's current spot within the habitable zone carries no permanent guarantee attached. It stands as a temporary alignment, destined to shift as our star itself continues evolving naturally across time. Researchers studying planetary habitability increasingly emphasize that the habitable zone represents only a necessary starting condition, not a guarantee of actual habitability on its own. Confirmed examples like Mars, sitting within a broader version of this zone yet remaining hostile and dry today, demonstrate clearly that location alone never determines a planet's fate completely. Scientists studying exoplanets discovered around other stars have found many worlds technically positioned within their own star's habitable zone, yet showing no confirmed evidence of the additional supporting factors that actually make a planet livable in genuine practice. Earth's comfortable, life-sustaining position within our solar system rests upon a considerably narrower and more fragile combination of factors than most people ever pause to consider during an ordinary day spent under a calm, blue sky. Our own safe zone stays this narrow and temporary by nature. Our entire solar system continues moving through the wider galaxy surrounding us, drifting toward a destination that remains genuinely unknown to anyone studying it today. Our entire solar system, every planet, moon, and scrap of debris discussed throughout this journey does not sit still within the wider galaxy surrounding it. Confirmed measurements show our star, along with everything orbiting it, moves through the Milky Way at considerable speed, completing one full orbit around the galaxy's center roughly every 230 million years. This galactic journey carries our entire solar system through vastly different regions of space across time, some calmer, others considerably more crowded and potentially hazardous to pass through. Confirmed astronomical mapping reveals our system periodically passes through denser regions of the galaxy, including areas holding significantly more stars and interstellar material than our current relatively quiet neighborhood. Scientists confirm we currently reside within a relatively sparse region, sometimes called the local bubble, an area of unusually low-density interstellar gas surrounding our solar system entirely. Researchers continue actively studying exactly how this unusual local environment formed, with leading theory pointing toward ancient nearby supernova explosions having cleared out the surrounding material long ago in the past. As our solar system continues its slow orbit around the galactic center, confirmed calculations show we will eventually move beyond this current sparse region, potentially passing through considerably denser areas where interactions with other stars and interstellar material become statistically more likely to occur across these vast stretches of time. Researchers studying galactic dynamics have confirmed that close stellar encounters, while individually rare across any given human lifetime, become considerably more probable when measured across the kind of enormous timescales our solar system actually experiences throughout its galactic orbit. Passing through denser regions of the galaxy increases the statistical likelihood of a star passing close enough to meaningfully disturb the distant Oort cloud. potentially dislodging considerably more icy material than the relatively gentle disturbances expected within our current sparse cosmic neighborhood right now. This does not represent an immediate concern by any reasonable measure available today. The relevant timescales stretch across millions of years, far beyond anything resembling immediate human relevance to worry about. Yet it confirms something important about our solar system's true nature, an object in constant motion through a galaxy that is itself far from static or predictable in its own right. Confirmed astronomical research shows our entire galaxy sits on a collision course with a neighboring galaxy, an event expected to unfold over billions of years into the distant future ahead. While individual star collisions during this galactic merger remain statistically unlikely given the vast distances separating stars even within crowded galaxies, the event will fundamentally reshape the galactic environment surrounding our solar system entirely. Scientists modeling this distant future event confirm our solar system will very likely survive the merger intact as a working system, even while the broader galactic environment surrounding it transforms dramatically across these enormous timescales ahead. Researchers continue refining these long-range models using updated data collected from observatories around the world. Our solar system stays far from a fixed, unchanging structure sitting quietly within an equally static galaxy. It exists as a system in constant motion, carried along an enormous galactic journey whose future details remain considerably less certain than the comfortable stillness we experience within any single human lifetime. After everything explored across this entire journey, one final, sobering truth remains waiting to be confronted directly. We have traveled across our entire solar system together, from the rocky debris crossing Earth's own orbital path, through worlds stripped of their atmospheres, past storms larger than entire planets, and finally out toward the mysterious, icy boundary surrounding everything we call home. One final truth connects every single discovery found along this entire journey. Nothing protecting us today carries any permanent guarantee. Confirmed scientific evidence shows Earth's magnetic field, the very shield protecting us from the solar particles that hollowed out Mars billions of years ago, has weakened and even reversed multiple times throughout our planet's long and turbulent history. It will almost certainly do so again at some point in the future, according to the consistent pattern revealed within confirmed geological records studied closely. Our protective atmosphere, the thin layer separating survivable conditions from the crushing, toxic hostility confirmed on neighboring Venus, exists in a delicate balance shaped by countless interacting factors, several of which remain incompletely understood even by the scientists studying them most closely today. The Moon, confirmed to be slowly drifting away from us with each passing year, currently stabilizes Earth's tilt and seasons across the calendar. Eventually, according to confirmed long-term calculations, that stabilizing influence will weaken considerably as our distant companion continues its slow departure into the dark. Jupiter, confirmed to deflect dangerous objects away from the inner solar system, simultaneously redirects danger toward us as well, an imperfect, double-edged form of protection, rather than a complete and reliable shield standing guard above. Earth's habitable position, confirmed by scientists as residing within a remarkably narrow zone, carries no fixed, eternal guarantee attached to it. Our star continues gradually brightening over time, confirmed through detailed stellar evolution research, slowly pushing that narrow habitable boundary outward, away from Earth's current orbital position, across an extraordinarily long but ultimately finite timeline ahead. Even our solar system's relatively calm, sparse position within the wider galaxy, confirmed today as a fortunate, quiet cosmic neighborhood, will not remain unchanged forever, as our entire system continues its slow orbital journey through considerably more crowded and complex regions of the galaxy over time. None of this should be mistaken for impending, immediate danger waiting just around the corner. The vast majority of these confirmed risks and changes unfold across timescales, stretching across millions or even billions of years, far beyond anything resembling genuine, immediate human concern within any of our own lifetimes to witness. What this journey reveals instead runs considerably more profound than simple fear. Earth's stability is not a fixed, permanent state of existence locked in place forever. It stands as a temporary, remarkably fortunate alignment of countless interacting factors: a magnetic field, an atmosphere, a stabilizing moon, a protective neighboring giant planet, and a habitable position relative to our star, all working together in careful balance across this particular, narrow window of cosmic time. We exist during a uniquely fortunate moment within an otherwise turbulent, ever-changing system, surrounded by forces capable of enormous destruction, yet currently, remarkably, held in careful, temporary balance against the odds. The solar system runs far stranger, far more violent, and considerably more fragile than most people ever pause to consider during an ordinary evening. And somehow, against truly enormous cosmic odds stacked against us, we remain here, watching it all unfold, one quiet night at a time.